Hello everyone, welcome again to Incomplete Data Analysis, and in this part I will be providing you with a general introduction to the problematic of missing data and also some specific examples of missing data occurrence. And let's first start looking at the scope of the course. The major goal of this course is to provide you with an overview of the available statistical methods for dealing with datasets that contain missing values. And the application of the methods will be done using the R statistical software. We will be covering four major topics. The first topic, the one that we are starting today, covers the introduction to the missing data problem, and we will be learning concepts such as missing data pattern and missing data mechanism. We will then be learning about traditional or naive methods for dealing with missing data, and we will also learn about their drawbacks and why they should not in general be used in practice. In the third topic, we will cover likelihood-based approaches for handling missing data. And finally, in the fourth topic, we will learn about multiple imputation. We will be spending a considerable amount of time on multiple imputation because it is considered one of the state-of-the-art approaches. And just to give you an idea of how an incomplete data set might look like, suppose as an hypothetical example that we were interested on the effect of gender and age on income, and so a study was designed and data were collected, and suppose that the first 4 rows of the data set are shown here in this table, and as we can see, only for the first individual we have complete information on all 3 variables. For the second individual we have only recorded their gender, for the third individual we have only recorded their age, while for the fourth individual age is missing. So the question now is, how should we proceed? Imagine that I'm interested in fitting a regression model with income as the response variable and age and gender as covariates. A natural temptation would be to disregard all subjects that have missing information in some variable, and in this case we would restrict to our analysis to the first individual. And as we will learn in a few lectures, this approach of disregarding individuals with missing information does not lead in general to valid inferences and therefore should be avoided. And we should be aware that in this course we will be looking at second best solutions to the missing data problem, as none of the methods will be better than having the complete data set that was intended to be collected. And here I will be quoting Ellison, who is the author of a book about missing data, and he has written the following: the only really good solution to the missing data problem is not to have any. So in the design and execution of research projects, it is essential to put great effort into minimizing the occurrence of missing data. And this is a very important point. Sometimes we as statisticians or data scientists, we are not involved in the early phases of the study, and so when we receive the data set, if it contains missing values, we can do nothing but just try to minimize and correct for the presence of missing values and use the appropriate methods. But in case we are involved in the study design, there are some tricks that can be used to avoid the occurrence, or at least to minimize the occurrence of the missing data, and we will be learning some of these tricks in a few lectures. As I've said already several times in this video, in this course we will be learning about statistical approaches and methods for data analysis that has some missing values. And in many practical settings of interest, such as, for instance, sample surveys or clinical trials, data are to be collected according to a predetermined plan or design, and then the goal is, given the data that we have collected, to make inferences about some aspect of an underlying population of interest. However, to to several reasons, data that were intended to be collected and therefore would be contributing to our inferential objective are actually not collected or not available. And of course, this has the impact to this has the potential, to impact our inferences. And the next 3 examples illustrate different situations in which missing data can occur, and they are adapted from Professor Mary Davidian's notes. And the first example is about non or partial response in sample surveys, and sample surveys are very much prone to the occurrence of missing data. Suppose that, for instance, a survey is to be conducted and the goal is to estimate the proportion of a certain population that is likely to vote for a certain candidate, or alternatively, the goal is to estimate the features of the incomes distribution in a certain population of households. And the way things operate is that a random sample of subjects from the population of interest is contacted, for instance, personally or via a phone call, or alternatively, they receive a questionnaire either by post or email. And what happens is that for some participants in our study, they may not answer the phone or refuse to respond, or some others may fail to send back the questionnaire, or they might send back the questionnaire, but they might not reply to all the questions. And as we can easily imagine, then the quantities that we are interested in making inferences about, for instance, the features of the income distribution of the households, they will be impacted by the presence of missing values. And what we should do is, in our analysis, try to correct for the presence of missing values by using appropriate methods. And another very popular example of missing data are clinical trials. Imagine that we will run a clinical trial with the goal of comparing how effective 2 different treatments are. For instance, we are interested in checking how effective drug A is for controlling blood pressure against drug B. And the clinical procedure is as follows. The participants are recruited and enrolled in the study, and they are assigned, usually in a random way, to one of the treatments. So some of the participants will receive drug A and some other participants will receive drug B. And then they should take the treatment or the drug for controlling blood pressure in our example as prescribed, and they should come back to the hospital on a regular basis. And this can be on a weekly or monthly basis. It depends on the study, and every time they come back to the hospital, the relevant outcomes are measured and recorded. In the case of the blood pressure example, the natural outcome would be to measure and to record the blood pressure of the participants. And ideally, at the end, we would have a file where we have for each participant, the different time points, the recorded blood pressure, and whether the participant was assigned to drug A or to drug B. However, in these clinical studies that involve a time dimension beyond a certain point in time, some participants, they do not show up for any clinical visit, and therefore we say that they have dropped out from the study. And some other participants might quit taking the treatment as prescribed, or they might simply quit it at all. And further, for some other participants, they might miss some visits. For instance, they might come on week 1 and week 2, then they do not come on week 3, then they come back on week 4, and all of these leads to missing data. So, for instance, for some participants, if we think like a plot where on the horizontal axis we have the time points and on the vertical axis we have the blood pressure, for some participants we only have the beginning of their trajectory, or their trajectory up to a certain point in time, because after a certain point in time they have dropped out from the study. For some other participants we have trajectories that are at some points interrupted because they miss some visits to the clinic, and for some others, hopefully, we have the complete trajectory. But when when it comes to inferences, of course, these missing values will impact the inferences if we do nothing with respect to their presence in our data set. And as a third example, suppose that in a nutrition study, the daily average percent of fat intake in a given population is of interest. However, the accurate measurement of long-term fat intakes requires the subjects to keep a detailed food diary over a potential long period of time. And as we can guess, this can be extremely time-consuming. Without any doubt, a simpler measure would be to record all the food that the subjects have had in the last 24 hours. And what we are implicitly assuming is that this 24-hour diary is correlated with the long-term fat intake. Obviously, it is not a perfect measure of the longer fat intake, but it's instead an error-prone measurement of it. And in the literature, it is referred this 24-hour diary or the shorter diary as a surrogate for the complete detailed measure. And in order to reduce costs and subject burden, a study may be conducted in the following way. For all the participants in our study, we record their 24-hour fat intake. And only for some of the participants in the study, we record the more expensive and time-consuming full diary measurement. And in this example, the fact that some subjects are missing the longer full diary measurement is by design. In the previous two examples, in the surveys and in the clinical trials, we had missing data because it happened. It was completely outside of our control, while here, missing is completely under our control. We have designed the study in such a way that we know that some participants, we have the longer fat intake diary missing, and the fact that the missingness in this case is under our control, it has implications in the analysis. Right now, it's not important what are these implications, but it's important to have the idea that when missing data occur by design, we are in a better position. Let's keep this message. And what these three examples show us is that most studies involving human subjects are prone to missing values. And these missing values might be due to a variety of reasons. They can be due to mistakes made by the personnel conducting the study, or because the subjects refuse to participate, or they are unable to provide the required information. There are plenty of reasons why we might have missing values, but as a consequence, incomplete data is a routine challenge that often complicates the statistical analysis, because when some of the intended complete data are missing, depending on how and why the data are missing, and in the next videos we will be looking at these aspects on how and why data are missing, the validity of our inferences may be compromised. And on the top of this, most statistical methods assume that the data set is complete. And as we have already talked about in the hypothetical example, one natural option for the missing data problem would be to restrict our analysis to those subjects with complete information. However, as I have mentioned, and again, as we will see in one of the next lectures, this can lead to misleading conclusions in most of the situation. And this has led several researchers to acknowledge that we need to do something, or we need appropriate methods when we are faced with missing values. And the area of missing data analysis, fortunately, nowadays a very active area of research. However, I would say that the problem of missing values in data analysis is as old as the data analysis area itself, but it was not until the 70s that it was properly acknowledged and handled. And certainly, without any doubt, we can say that the game changer in this area was the article published by Donald Rubin in 1976, where he laid out a framework for thinking about missing data, characterizing formally how missing data can arise and elucidating possibly implications of missing data for inferences. And this is the seminal paper in the area, and according to a search that I've made on Google Scholar today, this paper has almost 10,000 citations, and this is an impressive number for a statistical paper. And for instance, last year, when I gave this lecture, I've made the same thing. I searched on Google and the paper had about 8,500 citations. So in the space of a year, almost 1,500 citations more. And here I leave you the front page, part of the front page of the paper. It was published in Biometrica in 1976, and the title was Inference and Missing Data by Donald Rubin. And Donald Rubin will be, the name of Donald Rubin will be appearing several times in this course because he's basically the creator of the area. So he came up with a lot of notions and methods. And it is everything for this video. I will be uploading some others on missing data patterns and missing data mechanism, but this is everything for now. Thank you.